All right, so this is practice, I can't remember, 7, I think, number 3. And let's do the one with the cars, okay? Oops, I don't think I have the pencil on. All right, there we go. Okay, all right, so 2 men who each weigh 650 newtons, each push with 200 newtons, moving a stalled 800 Newton car at a constant speed in a negative direction, okay, which means we're just going to be going this direction, okay, because to us, right is always going to be positive, okay, but that doesn't really matter anyway because it's at a constant speed. So the first thing you need to notice when it says constant speed, that means that the forces are balanced, okay, and again, in this unit, that's the only kind we have. So right now, everything is going to be balanced, okay? All right, so let's look for an interaction diagram. So here's the Earth. So let's see, the car to the ground has a normal, as do each of the guys pushing, okay? And since it's moving, they're also each going to have a friction, okay? And they're also each going to have a gravity. This is getting confusing, okay? And then they also are going to have this interaction with guy 1 pushing the car and guy 2 pushing the car. All right, so we're gonna have that. Okay, so let's look at the car first. All right, and then we're gonna have one of just one man, okay? So let's call one man M, and we're gonna call the other man B for boy, I guess, right? Just so we can kind of tell them apart, all right? Okay, so the car, first of all, let's put his force of gravity in because that's always there. So FG, CE, car, Earth. All right, and up, we know there has to be something balancing it because up and down, it's not even moving. So that has to be provided by the ground. So FN, the feeler's the car, and let's do G for ground. Okay, all right, and I know those two are going to be balanced because up and down, that's all we've got. All right, now let's think about what else is happening. So the men are pushing the car, and what is the car feeling? All right. The car feels pushed to our left, all right? And there are 2 of them pushing, so I'm going to have 2 separate forces. So I'm going to have FN car man, and then FN car, I'm going to call the other one boy, all right? So I'm going to have 2 separate forces because there's 2 men that are each pushing, all right? So if I see this much force to the left, I know I have to have an equal amount to the right since it's moving at a constant speed. And the only thing that could be providing that is going to be the friction. So that's FF, feeler is the car, okay, and the ground is the dealer. All right, so the dealer is always the ground when you're talking about friction. Okay, so the total amount that I have facing left has to be the same amount that I have facing right. All right. Okay, now let's just look at one of the men. All right, so he's going to have his own force of gravity. So force of gravity, man, Earth. And he also is going to be pushed up by the ground. Force normal, man, ground. Okay, feeler, dealer. Force, type, feeler, dealer. All right, now, the man is going to feel a force from the car. So if the man is pushing the car to the left, he's going to feel pushed to the right by the car. All right, so this is going to be this way, force normal on the man from the car. All right, and there has to be friction to balance it, so that is going to have to act this direction. So force of friction, man, ground. All right, okay, so let's see what kind of numbers we've got going on here. 2 men who each weigh 650. All right, so I need to go to the man's diagram. He is going to weigh 650 newtons. That's his force of gravity. Okay, and they each are pushing 200 newtons. So I need to go here where I see their pushes. They each are pushing with 200 newtons. All right, they're moving a stalled car that's 800 newtons. So that's the weight of the car. So that's going to be this one. All right, and I know all the forces are balanced because it's a constant speed. So let's take a look. If there's 800 down here, that means this is going to also have to be 800 newtons. Okay, and then to the left on the car, I see 200 and 200, which is a total of 400, which means the friction is going to have to be 400. Okay, now everything is balanced. All right, let's look at the man. If there's 650 down, there's going to have to be 650 up from the ground. All right, and now I don't know anything else, so I have to go look for the pair. So MC is my two objects here, so I need to look for this one. See, CM right here. That's going to pair with this one, MC. So that's going to be also 200 newtons. All right. So if the man feels pushed 200 newtons by the car, the friction on his feet is going to have to also provide 200 newtons so that that stays balanced, which keeps him moving at a constant speed, right? Remember, balanced forces means no change in motion. It can still move, it just can't change. All right, so that completes that one.